All right, ready to go. Hello, everyone. Welcome to this i3.net webinar. I'm joined here today by Martijn Schmidt. He's our head of network.
Hello.
Today, we're going to talk about internet connectivity and how businesses can leverage, basically leverage it properly for low latency applications. So game hosting, WebRTC applications, enterprise applications as well. And before we get into it, let's first say that at the end of the webinar, we have a live Q&A. So if you're watching this live, you can leave your questions down below in the comment section, and we'll get to it at the end of the Q&A, or at the end of the webinar, excuse me. And we also have a little short feedback form. We'll put that in the chat as well, and you can leave your feedback about this webinar over there. First question, if you guys want to answer it in the comments as well, where are your users from? Where are the majority of your users from? We're really curious to hear about that, and interested to learn from you guys as well. So let's start. I think the first question to start with, Martijn, is how do you optimize internet connectivity between users and on a global level, if you will? So how do you do that? And before you start, we kind of discussed this before, and you explained this concept of the default free zone. So let's start there. And it's basically as your data leaves the ISP or internet service provider, correct?
Yeah. So basically, while the traffic is still inside of the ISP, you cannot really influence it from an external perspective.
Right.
But at a certain level, you are starting off with your ISP. You are handing off all the traffic to that ISP, and you're telling them to basically figure it out. Where does it need to go? How does it get there?
Yeah.
And at a certain point in the ISP network, it's reaching a level where there is no more default route. You can't just throw it over the fence anymore.
Right.
And that is when we are reaching the so-called default free zone, because there's no more default route.
Right.
And in that default free zone, you need to keep in mind that there's around 900,000 unique IPv4 routes, somewhere around 100,000 IPv6 routes.
Right.
Somewhere in the direction of 100,000 unique autonomous systems, so unique ISPs, as it were.
Right.
And at that level, basically, there's a couple of tiers, and I think it's helpful that we start at the lowest.
Yeah.
Basically, at the bottom tier, you're buying from one transit provider, and that transit provider is basically, well, for all intents and purposes, your default route.
Right.
Then the next tier, let's say you are buying from two different providers, and you are mixing the two feeds together, and you are letting a routing protocol like BGP do its thing to figure out what is the best path to get to your destination.
Right.
And that means that you can basically cherry pick the best of both worlds from your two different providers. In addition to having redundancy, you can also, for example, combine the good trades with the good trades to get the local routing always.
Right.
Then you've got so-called tier 2 providers that are, besides buying transit, also interconnecting directly with other tier 2 or tier 1 providers in a thing called pairing. That's basically where two providers of an equal size or somewhat equal size or importance determine that, hey, you've got customers that are paying you, I've got customers that are paying me.
Yep.
If we are making a direct connection between us and handling only the traffic that we get paid for, then it's somewhat equal, and we don't actually need to charge money to each other.
Right.
And so that is basically what mainly decentralized the internet, that behavior.
Yeah.
Because that's why you have so many different unique routes and why you have so many different ways to get there. And lastly, you've got tier 1 providers, and those are providers that do not buy any transit, but they are only doing peering, or they can reach you as a customer. So basically, they are at the top of the food chain, as it were.
Right.
And when we are talking about those providers, you are talking about having a backbone to get from, let's say, the Netherlands to the other side of the world, or from other part of the place. and the tier 1, 2, or the tier 2, 3, and 4 providers basically don't have to have a backbone. They can, but they don't always have this. Whereas the tier 1 provider, it's literally their business to hold the packets around. Doesn't mean they're going to be present on every continent. For example, there are some tier 1 providers only present in North America. But every European tier 1 provider must also be in North America, because otherwise they can't reach those that don't operate outside of it.
Right.
And the same for Asian ones, etc., etc.
Right.
So these.
So by working together with all these different providers, you're able to find the optimum way to basically interconnect between, different users around the world, or from a certain server location to the users, if you will.
Yeah, right. So apart from the fact that you've got like the transit provider that you can throw over the fence, and they basically use their backbone to get to the place where you need to go. And usually these backbones are optimized for cost. So the provider gets paid the same amount whether they are delivering the traffic in the same country, the same city, or on another continent entirely. So you can imagine that they are going to do everything in their power to get rid of it as soon as they can, right? Because that's the commercial model of that business.
Right.
But tier 2 providers like ourselves, for example, have also decided to build their own backbone, so that we can keep control longer of how the traffic is routed, where the traffic is routed.
Right.
And more importantly, what path that it takes, right? Because not all paths are created equal. In fact, I already mentioned like North America and Western Europe as kind of the core locations of the internet where things are just flowing towards on their own without too much effort. But as soon as you go to, let's say, even Eastern Europe or Africa, Latin America, Asia, it's no longer a given that your traffic is going to stay local. So there's really a difference between, let's say, a provider that's going to route the traffic from Japan to Japan via Los Angeles, or one that does it within the same country or the same city.
We will talk about these different harder to reach locations later on, because I think there's a lot of opportunity there for the future as well. But I think it's good to stress that we are really, the internet as it is really a fiber optical cable system at this point.
Yeah, right. So it's really a terrestrial or subsea type of deal. So you hear a lot of buzz about satellites and other wireless communication technology, but the throughput of those technologies is not quite at the level of subsea cable or terrestrial fiber pair.
Right.
So to give you an idea of the order of magnitudes, you're talking about gigabits of traffic if you've got a pretty good satellite, and you're talking about terabits of traffic. So that's an order 1,000 magnitude larger for a subsea cable, for example.
Right. So these high throughput applications we referenced before, like gaming, which is a lot what we do, but WebRTC, they are just satellites just can't handle the amount of users.
The generic internet, as it were, cannot handle that amount of users. Like you can use it as a way to get to difficult areas like rural areas. It's great to have a satellite connection or some other wireless, because you don't need to dig all these miles of fiber.
True.
But when you are talking about a high throughput, long distance network, fiber optical is almost always the way to go.
Right. Let's try and jump into more local levels. So we talked about on a global scale, kind of how you can optimize things. But what are the kind of the things that you run into when you try and optimize on a more localized level?
So on a more local level, as I said, Western Europe, North America, it's relatively easy. But when we are looking outside of those regions, it quickly becomes a matter of making sure that you've got the right interconnections in place with the providers that are important to that region.
Right.
Like if you are buying from an American provider and the American provider is a new entrant to the market in, let's say, South America or let's say Asia, then they are likely not to be super well interconnected. So you need to make sure that you make your own connections or you buy from a provider that does.
Right.
And so in some regions, there are also political considerations like people wanting to be the biggest ecosystem owner or operator in a given area, or people that want to protect their home market, or we've even seen cases where the government has decided to regulate the interconnection market to a point where it's actually scaring everybody away from coming local to that country. So the opposite of what the government intended, it's actually happening as a result of that.
Yeah, it makes sense. So we talked a little bit about how we can optimize things and what the internet basically, how it works and how we can try and make some optimizations, as you will. But let's talk about how does this affect the real-time traffic. So I mentioned a couple of examples earlier. How do you properly optimize for that, and what are really the effects of all these things that you're optimizing?
Well, I think that the main takeaway there is that a lot of the internet traffic is cacheable, right? If you've got a website and you're reading the news and 50 people read the news, they're basically requesting the same page all the time and they get the same output all the time. So you can basically cache that content in lots of locations and you can serve it out from there 100 times, 1,000 times, 1,000,000 times. It doesn't matter. It's the same. But with real-time traffic, the problem becomes that you can't cache it. Like you can't store the flight of a soccer ball going to a goal or a car driving around the corner while there's somebody else trying to bypass outside around. So you have to really make sure that there is a real-time communication between these things. And after you basically went through that moment, it's no longer there. So all this traffic really lives in the moment, and especially for multiplayer or traffic where there's multiple parties interacting, let's put it like that. And this can mean a voice or video chat, or it can mean a game, or it can mean something else that is like that. You need to do that in a centralized location, or at least a semi-centralized location, so that you can bring enough of a pool of people together that at all hours of the day you are able to start, let's say, a match, or that at all hours of the day you're able to find somebody of equal skill. Because if you are at the top of your field in the sport that you're playing on the game, and somebody else is only just beginning, then you are not going to have a super great user experience.
And the less amount of players that are in the area, the less choices they have in order to properly match those things, not just in terms of skill and latency as well.
Exactly. Sometimes, in fact, it can be better to play with a greater latency, but at a more equal skill level. For the end user experience. So where a lot of the traffic and a lot of the internet is optimized for a short haul connectivity, actually there is always a long tail of people that are either unable to get match made properly in their local region, or they are going one hop further, or for example, if I happen to have a friend on the other side of the world, let's say I'm in the Netherlands and somebody else is in Los Angeles. There's no way around it. One of us is going to have to travel to interact, right? So it's unavoidable that sometimes you are going to have legitimate reasons to go over a very long distance. And that's where the real-time aspect kicks in. And why you need to agglutinate as much user base from a larger region into your locations. So really the challenge that we try to deal with is our locations need to be good for everyone in the area rather than that single country or that single metro area.
I see. So we talked about some of the issues and how you can resolve it, but let's talk about a couple more things, how you can mitigate some of the issues that we talked about. So we're not just skill level, but mostly latency and these interconnectivity. Interconnectivity is not ideal all around the world. So how can you mitigate those things properly? What is the best way to do so?
So we spend a lot of time doing outreach to the ISPs that are not in, let's say Western Europe and North America. And so we try to talk with them to figure out how we can interconnect directly with them and basically eliminate the middleman. Because if it's just two parties that you need to talk to, one of whom is interested in fixing it because that's what their customers want, and the other one who has a support ticket and also is interested.
Yeah.
Like you can get rid of issues a lot faster than when you have to interact through 3, 4, 5 different layers. That is the first part. The other thing is that if you do have to travel across long distances, then if you are able to do that on your own infrastructure or on infrastructure that is at least optimized for that,
or controlled,
for that, then you have much more influence over the quality of that connection.
Right.
Like you can make sure that, for example, you are not going to go from city A to B via some city C totally somewhere else.
Right.
And sometimes, it means that you are basically going against the commercial flow of the internet. For example, if you're talking Eastern Europe, almost everything is going to Western Europe.
Right.
But if you want to have a north-south connection, well, good luck finding that in an affordable manner without having to first go west to a point where everything is somewhat converging and then back east again to go to your final destination. So these are the types of things that we try to eliminate as much as we can.
And this is a nice little segue into what we wanted to talk at the end of this, and this is the final question as well. Is that how do you see internet connectivity progressing in the future, and where do you see it going? Because we talked a little bit about the north-south and the east-west. I think on some of the in the southern hemisphere, you mentioned some of the continents that are most affected.
A lot of the internet is currently either going in a north-south manner, moving across the globe, right? Like from South America, everything goes up to North America before it goes east-west to Europe or Asia. Likewise in Africa, it goes north-south before going east-west. And that type of thing exists a lot.
So if you're going from South America to, let's say, South Africa, you're basically going in an N shape, right?
Exactly. You're going in an N shape or inverted U shape, however you want to call it.
Right.
So it's super inefficient because you have to go to North America first, cross the ocean again, and only then are you at your final destination.
Right.
And you can basically shave 2/3 of the latency away if you are able to have a direct connection between South America and Africa in the southern hemisphere.
Right.
And so what we've seen over the years is that these cables have started to appear. So there's now since the last I think half decade, basically 2 cables that are between Africa and South America. We've recently seen the first cable between Europe and North America, or the second cable, but the first high capacity one being lit up.
Right.
We are seeing, for example, that Australia is now connecting into Oman and from there onwards to Europe. So rather than having to go through Singapore first.
Right.
So a lot of these new routes are being prepared to start handling users. But even when the actual physical infrastructure exists, doesn't mean that the ISPs are actually going to use it.
Right.
Because what we see is that sometimes those routes can be more expensive because there's not yet the economies of scale that you do have along the mainstream paths.
Or competition between the different cables.
Competition between the different cable operators. Yeah, exactly. Like, for example, the transatlantic market is super competitive.
Right.
Like, there's like so many different cables to choose from that there is always enough capacity for somebody to offer a reasonable price.
Right.
And so what you're seeing is that at the moment, everybody kind of has taken all these mainstream routes, but for the new, more exotic route or esoteric routes to be integrated into the internet, like not private backbones, but the actual internet.
Right.
I think we still have quite a few years ahead of us to try and find all the ISPs and get them on board with that project to make use of that infrastructure that has now been invested in. And even then, there are still corners of the world that are not connected in a somewhat direct manner, even though you would kind of expect it to be there.
Right.
Looking at, for example, the south of Africa towards Australia or Australia towards Latin America. Sure, it's a lot of distance and like probably similar, if not more, than compared to the current hops that they are making.
Right.
But if you happen to have family living there, then you're going to have pretty laggy experience when you're trying to call to your grandparents.
So
or
what
when
would
you
be the
try
best
to
way
play
to-
with your friends.
To establish those connectivity ecosystems, right? Because it's basically ecosystem developing themselves. Is it internet
Yeah.
exchanges establishing there? Is that the best way?
Internet exchanges is one thing of it, right?
Mhm.
Like as I mentioned before, if you are in another place, then somebody has to travel.
Mhm.
So that's one component of it. The other one is trying to keep the traffic more local.
Right.
So what we see sometimes is that certain countries, especially in, let's say, the Mediterranean / Western Asian area,
Yeah.
these countries have many cables that are passing by or that are passing through even.
Mhm.
But in those countries, it's simply not commercially viable, not even because the cables aren't there, because that's the mainstream route,
Right.
but because, for example, regulatory reasons that they're pricing themselves completely out of the market.
Right.
That, like, as I mentioned, transatlantic market is super competitive.
Right.
Like, you can easily find that the pricing for a cable that's going to, let's say, one of those countries I mentioned before,
Yeah.
is going to be 10, 20 times as expensive for the
Right.
same capacity, similar distance, similar technology.
Yeah.
It's just lending charges.
Right.
And I think that a big part of the problem with those lending charges is that while you are not a proven market, like Western Europe, North America, there's less incentive for those ISPs to start thinking about investing at scale into those newer hubs.
Right.
And while it becomes, or while it is so relatively expensive, it's hard to convince somebody to take the plunge.
That makes sense. But also you mentioned putting it close to the user. So you can also put compute close to the user, right? Data centers closer, and then you think that the connectivity would follow. But again, if they're priced out of the market, it's kind of difficult.
Yeah, and as I said, even if we were able or willing, or whatever, to throw a boatload of money at it, then it still wouldn't solve the problem if all the other ISPs that are operating these eyeball networks, for example, they don't follow suit.
Yeah. The internet day and day is a collaborative thing that everyone has
you
to
have
kind
to
of
actually cooperate.
the carriers,
to
the
be able to make it work.
ISPs, everyone has to kind of play along in that sense. All right. I think we've covered most of the subjects we wanted to do as far as I understand. So do we have some questions in the Q&A section?
We have one so far.
Okay.
It's a part question. What kind of pressures do metaverse and popular AAA games have on resources like CPU memory storage? And if this is a challenge, how do you overcome this through higher capacity, faster performance, or both?
So we are.
Should I just repeat the question really quick because it's quite a complicated one. I believe it was about basically gaming applications in metaverse and how do we overcome that in terms of resources, in terms of CPU memory storage. So that's basically on the server side, but also in terms of higher capacity or performance. Okay, that's an interesting question, but less related to connectivity, but it's still a good question. We're here to answer your question, so let's give it a shot. I mean, it really depends on the application, I think, at the end of the day.
What we see is that mainly the game applications are often very CPU intensive. Like there's a lot going on in the world and you need to keep track of it. Likewise, the bigger that the world is, the more memory that it consumes, right?
Right.
So those are where the pressures are. And I think that game provider or game developer would always like to have more resources of everything, but at some point you can't keep scaling that on a single node.
Right.
So it's not so much that you're scaling vertically, it's more that you have to scale horizontally and like decentralize your infrastructure as much as you can.
Right.
So that you are able to scale out rather than up.
And there are other applications that are maybe a little bit more bandwidth intensive.
The metaverse thing was actually an interesting example because if you are, for example, going to take rendered video traffic and you're going to pump that across the wire back and forth, I think that's where a lot of bandwidth will be required. But again, the question is, where are you going to be able to handle that traffic, right? Because if you are able to put, let me say it this way, if you are interacting with somebody, that's real-time traffic, and you have multiple parties that are involved in that, and that means that you need to centralize. But if you are a single party then consuming the output from that calculation, if you will, the rendering can take place much closer to the end user. In fact, there is only a single user that is consuming that rendered video feed.
Right.
And so you can put that much closer to the end user and become less reliant on the backbone.
Right.
By having that, in the same country,
that could also,
city, whatever. Yeah.
So if you're looking at metaverse, it makes sense to put compute closer, data centers closer to users rather than
to some extent,
massive
right?
data centers out in the middle of nowhere. If you will.
Yeah. So you will not see one data center per continent anymore.
Right.
The Dublin sort of Oregons of this world.
Right.
But you will see in multiple interconnection hubs where enough ISPs are actually present to make it reasonable to deploy there.
Right. And that's I think that's about it.
Mm-hmm.
Well, I think we even stayed within the time pretty well, so pretty good, pretty well done. Is there anything else you wanted to mention that you didn't get to mention yet?
No, I think
we covered it, right?
Yeah.
Very good. All right. Well, thanks everyone for watching. Thank you, Martijn. Thank you so much. Yeah. And thanks everyone for watching.
Thanks for having us.
Catch you in the next one.
Bye-bye.
See ya.